configurations. The system is scalable. We can use more than one camera, one next to each other in different combinations for doing 360-degree scanning, or maybe with lower resolution but covering a large area. All this is possible with the tool, so it's quite flexible and quite easy to use. So for those of you who are not still convinced that calibration might be something really straightforward and needed, look at this object. These are teeth, reconstruction of a mound of teeth without calibration. That is just putting in 3D directly the range map, and this is after calibration. So this really looks more like what it is instead of that. Here you see that this angle is much different than this angle here. This is true and this is bad. So in this place here, we can say we have less than 50 microns accuracy, less than 50 microns absolute error reconstruction, and here we cannot say that. We can't even evaluate what is the error here. So this point cloud here is suitable for later manufacturing prostheses of teeth here. Now, I have showed you shortly a small overview of our tools, so generically. Now, you're going to see them in action. If you want to see them even more in action, please visit our booth. We're in B79 into the shell, in the other hall, without any waste. And one of the applications that I'd like to show you here is on display in our things. So you can see the first thing maybe the manufacturer unhappy, and the second thing maybe the first application is for food processing. So we have actually maximize slicing. So the strategy is pretty much the same, that we have made calibration in the food industry much easy, and also the specifications were much more relaxed here. So only 2%. When a manufacturer produces sausage, we use tuning cameras because the speed was not really an issue, and you want to go to the supermarket, the main one, the big detector to spend a long time converter tool and asking the measure calibration to mean for you how to cut the sausages. We probably want to find out. We have two cameras so that you pick it up, looking at the laser from opposite sides. So we see the same camera manufacturers are spending a lot from one side and from the other side. Make machines that automatically are doing slice, and we are doing with a fixed number of portions. And the good thing with that is that this number of portions compensate each other, so that the weight must be the same. This side you see there is no data to spend extra time waiting and labeling. On the other side, in the same place, we want to do everything in the same time. At it from the other camera, we have data. The idea is that if we can, and the result is that we have data. 360 degrees use that data to compute the tour volume of the sausage. The calibration by scanning this, we can compute the areas very straightforward, accurately, and we can integrate are supposed to be on also a conveyor belt, and we can have volume along the conveyor by assuming constant. So the calibration is using the very standard sausages here. So then we can just scan it as though it was a constant volume. Then we can also assume that we have constant weight, very high accuracy. With this idea behind to just use the calibration. It's just progressing after the acquisition. We get 120 degrees all around, and the object that is being scanned through the relationship between the laser coordinates and the effective manufacturing of we obtain of the object. The reconstruction, actually, we know which are around the coordinates of the place. Then we can put them in correspondence. We can see a combination between the big detector tool and the metric calibration tool. And once we have the reconstruction, it means we have no points here. We can use the area computation. Volume is exactly one of the new tools we have to reconstruct. The area computation tool to perform the integrate computation of the slice. With integrate the values within the. For you to have real images of these areas, the machine looks something like that. This is adding a special flavor of our calibration. We have this not full volume scanning. This is just one shot. And by having the full volume, we have one of the special data required. We have two conveyors, one input conveyor, one output conveyor with the inner small gap, and the other one is to have other parameters like the lag image from the top place, but also from the two sides of the same machine, so that we're able to reconstruct all around. After the volume is computed, there is an automatic sorting system that uses pneumatic automatic, as you see here, in this application we use photo-focused 3D cameras and classify the one into the volume. So that the laser is 50 different degrees corresponding to laser and camera, so that the customer can replicate it 3 times the feeling as you see here, and this is with the different values with a really minimized. The good thing with it is even with this small angles, again summarizing it's the absolute same accuracy approach here. Computing the area shells, coconuts are 0.2%. A natural product by fortune. So with this also have special different volumes from a customer. No choices are equal incorporated as a standard. Compute the actually this is a product that must be high accuracy computed. Customers are very glad because they have very little waste when they package. Since we also are accurate at estimating the slices, and as you see here, we reconstruct different slices. The yield is really minimal. By integrating the area summary of the two applications, main things of constant volume and pretty sharp, and then this information can be passed to any questions you may have. Thank you very much for your attention. So as a summary of this application, using laser triangulation, 3D and calibration, the packages with the same weight and the same number of slices in each package is possible at very high representation does. There is your thickness of each slice can be to each one. So you have points in the same coordinate system. You can volumetric information so that we make sure that with the same number of slices we get still the same weight. And the accuracy in the estimation of the accuracy in the field of view. But if it's very high, so then putting in extra cameras, you can have a very reliable weight design for objects, so that the 5 packages and we get in the supermarket, you can make sure that if they claim it's 140 grams, they are 140 grams, plus minus very little. Well, this has been the slicing application. Another application we don't have on display because our booth is very small and modest, so we can bring only one machine at a time, is this other application. If you ever had desserts in a restaurant, you might have seen one of the options is to have ice cream, okay? One of the very special ways to get ice cream, coconut ice cream particularly, is to take it out of the coconut shell. Okay, this is very common in Spain. So, as you can imagine, the ice cream manufacturer, what he wants is to pour